Hello, we are the team of Los Merengues, and we're going to be presenting our emergency drone service project of Internet of Things. So this consists of four parts. First is the introduction, where we talk about the problem and the motivation, the presentation of the technical architecture of how we're going to design the project, the installation of actually making it, compiling it, and installing it on a system, and the conclusion where we're going to show a demo of our prototype working for real. So technology and natural disasters. In the event of an emergency, technology is a resource that is very helpful for damage assessment, for real-time information and rapid response, as well as mapping affected areas and analysis to determine what kind of support the victims need. And that last part is going to be really important for our project because our plan is to deplete a fleet of drones to a place where there has been an emergency, where they can, the help of an app, declare their location and their severity so that the services may provide help for those who need it and prioritize the ones that are more important.
Well, here we find three diagrams: the diagram of cases, activities, and the database diagram. Here in the database diagram is where the scripts will be executed in the database and the clients of the Android app. We see that the node ID is the primary key, the severity, it's sent to the app, the risk depends from the severity and time. And here in the case, we check that the severity changes and it's updated by the publishing a message on the topic that through Mosquito subscribes and the users put in the database. And there will be another Python running where it stores the risk data and Grafana will show the information. Here we see the class diagram. We see that there are two participants, the client and the admin. In this case, we see that the admin is not a fundamental part of the development for the user, which is why it's outside of the class diagram. Here we see all the variables that the client will have in the app.
Well, now we're going to show how to install and compile our product. First of all, we need to go to our GitHub repository where you can find almost all the information we are talking about right now. And going through the sections at the part where it says getting started, we have the first title that says build with. This is important because here it says what are the most important technologies we are using for the application that are React Native, Mosquito, MySQL, Node.js, Java, Grafana, Android Studio, Microsoft Azure. Mininet isn't implemented yet, but it's a future plan. Starting with the steps, first we need to install our development kits. One of it is Node. We need Node.js 14 or newer. So in case you don't have it, you can install it. And also Chocolate is installed with it, that it is a application that we're going to need in further steps. Next, we need the Java development kit 11. It is recommended that it is this version because with the other ones, you need to modify some things in the Gradle folder. So moving on, we finally get to work with the emulation. You can use also a physical or device, but we used a virtual device created with Android Studio. We need to install Android Studio, mark, and follow all the steps that we have here. And we developed the app with the React Native library. Also following all these steps, we are going to get to clone our repository and our app into the Android Studio application and running it with the emulated virtual device or with the physical device. Now we can use our app. Just remember to modify the apps so it is connected to your database and in case you are using a virtual machine or a physical device. that, well, here we're going to this step because we need to create the virtual machine, or you can use a physical equipment like a laptop or a PC. We use Microsoft Azure to have a virtual machine with Ubuntu 2004. And we need to install some of softwares like MySQL, Mosquito, and Grafana. Starting by Mosquito. Mosquito is a TCP service that helps um, transferring information between machine and machine. It's a machine-machine service of transferring data. So by following all these steps in, remember, Ubuntu, we can next go to install MySQL and modify all our environment. So we can now next clone mm, the files that we got into the broker Mosquito for the Mosquito part. And next we need to go to the SQL database to copy our database. And finally, we need to install Grafana with these steps and modify it. So if you want to access to Grafana, you need to open the ports and so on. Now we're going with a demonstration of how the application works, that it is a demo.
Okay, so now I'm going to show you our demo creator for the client app. Here's the app.js made in JavaScript for and with library React Native. So here we have our emulator for Android, and then first at all I need to connect to the central Mosquito and then to the bridge broker. So 1 second. So now I run the bridge, and here all is connected. So I go back to the client to start the client. So I enter my IP and the broker where the Mosquito bridge is, that is the 1883. So here I connect, and it is displayed here, it was connected. So I'm going to start sending the message by clicking in one of these buttons that it states the severity that the message have to be sent. So then I click in hide, for example, and I update. It's going to be sent every 10 seconds. So when the button was pushed. So as you can see, here is the message sent, and this is going to happen every 10 seconds. Like if I click on medium, the next message is going to have a severity of medium. So here it is. And then for the subscribe to receive the message in the central, we have here a Python script that connects to the client with the broker and is going to also send all the data to the database that is stored in this IP with the user and the password created for MySQL. So I run this script.
Okay, so first of all, I want to state that we needed to move to our house or home because the network of the tech was like not allowing us to connect to the database, but we're going to explain all of that here. First of all, we have our client app made in JavaScript. This this code of the Android made in React Native. This you can find it in our GitHub. First, I'm going to turn on the central Mosquito and the bridge one. So here we are, and now we can now connect to the bridge from our client app with our IP and the port 1883. So we connect, and as you can see here, it was connected. So Now, what I want to do is to start our Python scripts. One, as well, you can find in the GitHub. This one is the subscriber and the ones that receives all the message and connect to the database and sends all the data, make a insert into our table message by the node ID, severity, risk, latitude, longitude, and here we have the risk script that basically this one is going to update every time the risk that was for one message, like for example low, when some message with severity low is sent, the risk is going to change every time 25 seconds happen. This just for demonstration, but this could be minutes, hours, etc. And the same for medium, and the same for high. When medium the time is 16 seconds, the risk is going to change first to medium and then to high. Now that I explained all of these scripts, uh, I'm going to start also this one. This was connected to the database and connected to the MQTT broker, and this one that also is going to be connected to the database. So this is executing. So now we can start sending message like medium, for example. I'm going to click on update, and every 10 seconds the message is going to be sent. Like if I click on load, as you can see, was sending a message. Now I can send a low message, and in the next 10 seconds going to be sent it. And as you can see, was sent another message with low severity, and here we can see that it was published right here in the bridge mosquito and the central one, and also in the subscriber with the risk executing at the set time. Now, my partner Ricardo is going to explain what is happening now in the database when this is receiving all of this message. So,
Okay, now here in the database, we can see that we are receiving the nodes with the severity, the risk, the latitude, longitude, and the date. So we use Grafana to display this data, and we can see here the node, yes, like, and the severity. Green is like low, yellow is medium, and red is in danger. Now, see, yes, so you can see it. If we refresh, there are my partner is sending medium, and also we make this bar chart where we can identify the number of nodes that are in low, medium, or high. And also we did this risk level that is going to update automatically with the time. So when we receive a low severity, in about like 20 seconds, it's going to change to medium and then to high, and we can organize the management of the rescue groups. And yeah, basically is that. Okay, so thank you, teacher, and I hope you like our project. And yeah, see you.